Hey everyone, so we're going to continue on our discussion with graphing quadratics to get solutions, and we're going to talk about quadratic linear systems. Basically what this is going to be is taking a quadratic, graphing it, taking a linear equation, graphing it, and seeing where they cross. Once again, they end up being the solutions. So remember that the solutions are sometimes called the roots, the zeros, or the x-intercepts, and these are the points where the graph crosses the x-axis. Also remember that we name polynomials based off of their highest power. Second degree polynomials are called quadratics, while first degree polynomials are called linear equations. So for example, this is your typical quadratic equation, while this is a linear equation. All right. Remember that the standard form of quadratic always follows this, ax squared plus bx plus c. Now, when I always gave this in the last unit, I always had this equal to 0, mainly because that unit focused on finding those solutions. So we always did want to end up having it equal to 0. But now that we actually want an equation to graph, instead of it being equal to 0, we're going to set it equal to y. Now we do the same thing where if we want to find the solution, we just turn that y equals to 0. But if you're going to plug this into a calculator, you have to actually include the y equals part. And then whenever you graph a quadratic, it'll give you a parabola. If you graph a linear line, it's going to be, as the name implies, a line. All right. So in the next questions, what you're going to be given is a quadratic equation and a linear equation. And you're tasked with basically graphing it, seeing where they cross, and then seeing if those end up being the solutions to both equations. Now in this first one, pretty much similar to the other question, I want you to try to think about if you were to graph a quadratic function and a linear function on the same graph, what do you think 0 solutions, 1 solution, and 2 solutions would look like? So pause video, work on yourself, and we'll go over in a second. So 0 solutions, if you recall, for a quadratic, that meant that it didn't cross the x-axis. But here, now that we're including this linear function, the solutions means where they cross. So similar to that one, this means that they do not cross at all. So maybe you have a parabola that looks like this and a line that looks like that. So they never get close to each other and they never cross. So this would be 0 solutions. One solution will be where it only crosses one time. A perfect example would be something like this. And then it just kind of just touches. I know I didn't really draw it that well, but it just touches at one point and only one point. And then two solutions, you'd have your parabola, and then the line would go through two times. So 0, 1, and 2 solutions. All right, so using all that, pause video, work itself, and we'll go over in a second. All right, so if you try to graph this, you'll end up getting a parabola that looks something like this, with this line crossing at around, I'll give it about 2-ish, and over here at about -3. And then when you graph your linear line, it'll end up going crossing here and crossing at this point. Now, if you are looking on the calculator, there's not going to be a whole number. The number that it ends up crossing out, let me just do the math real quick, ends up being at 1.83 and at um, -3.83. All right. So we can actually check to make sure these are solutions by taking these numbers and plugging them in and seeing if they equal 0. But I'm actually going to solve this a little bit differently. So what I'm going to do is, since the solutions here will be where these two cross, that means their y values are going to be the same. So I'm going to set the negative x equal x plus 1 equal to the x squared plus x minus 6 and solve it like a quadratic. So I'm going to add the x over minus the 1, add the x minus the 1, I get x squared plus 2x minus 7 equals 0. I'm going to do a quick quadratic. So negative b plus or minus the square root of b squared minus 4ac, which would be plus 28 all over 2. So this ends up being negative 2 plus or minus, that's going to be 32. Um, that could be rewritten as 4 root 2 over 2. So this can be rewritten as negative 1 plus or minus 2 rad 2. If you plug this in, you do negative 1 plus 2 rad 2 and negative 1 minus 2 rad 2, you'll end up getting these same numbers. So this also verifies the solution. Again, because these are kind of decimal and weird numbers, I would just I would do it something like this. If they give you better numbers, I would plug in the whole numbers instead. So how many solutions are there? There's 2, and they are written in proper form: negative 1 minus 2 rad 2 and negative 1 plus 2 rad 2. And once again, these are both irrational solutions. All right, here's the next question. Pause the video work itself, and we'll go over in a second. All right, so once again, if I were to graph this, the quadratic equation will look something like this. It'll cross at around negative 6 and 2. Of course, my graph's not really drawn properly. And then the line will end up crossing like this. It'll cross here, and it'll cross here. The locations where they end up crossing will actually end up being negative 4 and 2. So once again, there's 2 solutions, and it's negative 4 and 2. If I take these numbers and actually plug them into here and see what I get for y, I can do that really quickly. So for the quadratic, if I plug in 2, I end up getting 2 squared plus y equals minus 4 times 2 plus 12. So 2 squared is 4 plus y equals negative 8 plus 12. Negative 8 plus 12 is going to get me 4. So I end up getting 4 plus y equals 4. So y equals 0, which makes sense. That's where it crossed the x-axis. For the linear line, if I do 2 again, I get y plus 2 times 2 equals 4. Remember, I'm just taking these numbers, plugging them in for x. And I once again get y plus 4 equals 4, or y equals 0. So plugging in 2 into either of these equations, I get y equals to 0 both times. If I did the same thing for negative 4, I'd end up getting, I'm just going to do the math real quick. I end up getting y equals about 12. And then if I do it here, I end up getting 16 plus y equals positive 16 plus 12. Subtract the 16 over and cancels both sides. We get y equals 12 again. So again, regardless of whether I use 2 or negative 4, I get the same solutions. You could have also solved it the same way I did before, where I set the y's equal to each other, the quadratic and the linear equation, and then just solve like I did in the last unit. All right, here's the last question. Pause the video work itself, and we'll go over in a second. All right, so this one is a little bit different. So if I try to end up graphing this, um, you'll end up getting something that looks like this. And basically this means there's no real solutions. So how many solutions are there? There's zero. They are non-real solutions. I don't know how much you remember from algebra from before, uh, but what we mean by real is that they are either rational or irrational. So I'll actually prove this algebraically just to double check. So I'm going to find it the same way, setting these equal to each other. X squared plus 2x plus 8 equals 2x plus 3. Move the 2x and the 3 over to the other side. And I end up getting x squared. I have a 2x and a minus x, so these actually cancel out. And I end up getting 8 minus 3, which is 5. When I solve this, I can actually solve it right away. I subtract the 5 over and get x squared equals negative 5. Take the square root of both sides and end up getting x equals plus or minus the square root of negative 5. Now, if you remember, you might have learned this in a previous algebra class, but you cannot take the square root of a negative number. This is what we mean by real versus what we call imaginary. Real numbers, when you take the square root, they're positive underneath. So we can actually get a number. But here, the way we have to do is we rewrite this negative as an I. So our solutions would be plus or minus I square root of 5, which is called an imaginary number. So basically the main takeaway is that there is no solution to this because taking the square root would give me a negative number. It is not real and therefore not a proper solution. So that's pretty much it. Not every quadratic linear equations will give you a solution. Typically, if there is no solution, it's because it's most likely an imaginary number like this. For the most part, you ignore those, and you would just say there's no real solutions. All right. Once again, if you have any questions, let me know. Send me a message on Remind or ask me in class. Otherwise, good luck, and I'll see you later. Bye.